Hey, this is lesson 4.3, the video lesson, and you should be on page 274 in your book. In today's lesson, you're going to learn how to multiply fractions, which we've been doing quite a bit on homework, so hopefully this isn't too new. Now, in example 1, we just have a very simple example, and it says find 1/3 times 1/4, and in this one, there's just no bow tie reducing. So just to remind you what you do when you multiply fractions is you're going to multiply your numerator times your numerator, and your denominator times your denominator, and always make sure your answer is in simplest form. So when I do 1 times 1, I get 1. 3 times 4, I get 12. 1/12 is in simplest form. That's the basics. Now when we go down to the got it problems, they're still going to be pretty basic problems, but there may be some bow tie reducing in at least 2 of them. So let's start off, just do problem A. Okay, so do problem A. Pause the video. When you're done, restart it. Go. Okay, let's see how you did. So as I go over problem A, I'm going to remind you to look for bow tie reducing. So see if this one had it. And I will draw the little bow tie to remind you what it should look like. So let's start off. Before we solve the problem, we look to see if the fraction 1/2 can reduce, and it can't. And I'm going to look to see if 3/5 can reduce, and it can't either. Then I check for the 1/5. It can't reduce. Remember, any fraction that has a 1 in it won't reduce. And 3/2 also doesn't reduce. So the bow tie just tells you the 4 directions you should check for reducing. Now when you solve, you're just going to multiply your numerators times your denominators. So 1 times 3 is 3, 2 times 5 is 10. It's not improper, can't be reduced. Simplest form, final answer. All right, now we're going to go and we're going to do problem B together because there is bow tie reducing in one of your directions. So here's what I want you to do. I want you to take a second and I want you to look at the 1/3, the 3/4, the 3/3, and the 1/4. And see if you can figure out where the bow tie reducing is going to be. All right, did you find it? And it's my favorite type of bow tie reducing. These 3's can reduce. So the reason it's my favorite is because when they're both the same number, they go into themselves 1 time. So in other words, they're going to change to 1s. And that's going to make my life so much easier. Now, the 1 and the 4 going diagonally can't reduce because there's a 1 involved. So this 1 is going to stay a 1, and this 4 is going to stay a 4. Now the way I set up this problem, you don't have to set it up this way, but some students like, because it keeps the numbers all organized, that's the way I have the numbers at the corners of the bow tie. So if you like that, go ahead and do it. You don't have to though. So when I multiply my numerators, 1 times 1 is 1. The denominators, 1 times 4 is 4. It is not improper, and it can't be reduced because we got the bow tie reducing in the problem. All right, so B should have done with me. But now C, you are going to try on your own. But here's the thing. There is bow tie reducing somewhere in this problem, and I want you to find it before you multiply. So do problem C on your own. Pause the video, restart it when you're done. Go. All right, let's see how you did. Did you find the bow tie reducing? First, the 2/3 does not reduce, and the 5/6 does not reduce. Going diagonally, the 2 and the 6 will reduce because they're both even, and the 3 and the 5 do not reduce. So let's talk about how the 2 and the 6 reduce. So you want to think what number goes into both 2 and 6, and that would be 2. So 2 goes into both of them. Now, when you reduce, you got to think how many times does 2 go into the 2 and the 6. So 2 goes into itself 1 time, and 2 goes into 6 3 times. So now when you multiply, you get your numerator, you get your denominator. It's not improper. It can't be reduced any further. That is your final answer. Now just to show you what would happen if you missed bow tie reducing, if the problems are easier, it's not that big of a deal. It's when we get to bigger numbers that it is a big deal. So I'll show you what will happen. If you just did 2 times 5 is 10 and 3 times 6 is 18, now you have to reduce your fraction in the end. And instead of dividing the problem by 2, you're going to divide your answer by 2, and you'll get I'm sorry, wrote the wrong number. You'll get 5/9, which is the same thing we got before. All right, let's go on to the next page. So on this page, this is where they're actually going to be teaching you, if you read through this, about Bowtie reducing. And they just call it simplifying before multiplying. So I'll show you example 2 and 3 real quick, and then I'm going to have you try some problems below. So in example 2, let me zoom in nice and big so you can see it. Here's what I would do. First off, I look all 4 directions. Think of the bow tie. And if you like to draw the bow tie, draw it. 3/4 does not reduce. 5/6 does not reduce. 3/6 does reduce. And 5/4 does not. So 3 and 6 reduce because 3 goes into 3 and it goes into 6. So 3 goes into itself 1 time and 3 goes into 6 2 times. And when I multiply, I get 5/8. It's not improper. Simplest form. Now in example 2, you'll see we have a fraction times a whole number. So first thing I'm going to do is write the 18/1. So I have 2 fractions. Now I don't like the way the numbers are crooked like that. That's a little bit of my OCD. So I'm actually going to write the problem next to it. So I'm going to write 4/9 times 18/1. You don't have to do that, but again, that's my OCD. So now I'm going to look for some reducing. So 4/9 does not reduce. The reason I know that is 4 doesn't go into 9. And the only other thing that goes into 4 is 2, and 2 doesn't go into 9. So they don't have anything other than 1 that's common. And 18/1 does not reduce. Remember, if one of the numbers is a 1, there's no reducing. 4/1 does not reduce. Again, there's a 1. And 9/18 does. Now, the biggest thing that goes into 9 and 18 is actually 9. So 9 goes into itself once. 9 goes into 18 twice. Now when I solve, I multiply my numerators. 4 times 2, which is 8. I multiply my denominators. 1 times 1, which is 1. Since that is an improper fraction where the numerator is larger than the denominator, you have to divide to simplify it. You divide your numerator by your denominator, and 8 divided by 1 is 8. The shortcut is you just get rid of the over 1 part, and the numerator is your answer. All right, you ready to try some? Because here's what I'm going to assign. Your job is to do D, E, and F. I can promise you there is bow tie reducing in each one of these problems, and some of them might have it in more than one spot, so look carefully because that's what we want you to get good at. All right, pause the video, do these 3 problems, restart it when you're done. Go. All right, let's see how you did. So I'm going to go through and capture the bow tie reducing. First, my favorite in this one are the 4s because they go into themselves 1 time. But now I have to do the 3 and the 9. 3 goes into itself once, and 3 goes into 9 3 times. When I multiply my numerators, I get 1. My denominators, I get 3. That is simplest form. If you had 1/3, give yourself a C. Now in E, there's even more bow tie reducing, but I know there's a spot that lots of students miss. Now usually they see the 5 and the 10. 5 goes into itself once, and 5 goes into 10 twice. But usually they don't see that 6 and 9 bow tie reduce because they think, oh, 6 doesn't go into 9. But what is the biggest number that goes into 6 and 9? And that would be 3. So you can actually put 3 into 6 and 9. And 3 goes into 6 2 times. And 3 goes into 9 3 times. Now when I multiply, I get 1 times 3 is 3. 2 times 2 is 4. 3/4 is simplest form. All right, and last one in problem F, I'm going to start by writing the 10/1, and you know I have to rewrite that. I can't let it sit like that. And now I'm going to do some bow tie reducing. Nothing for the 3 and the 1. Nothing for the 3 and the 5. Nothing for the 1 and the 10. But the 5 and the 10 do. 5 goes into itself once, and 5 goes into 10 twice. I'm also going to write that 1 and 3 there. Now when I multiply, I get 6 over 1, which is 6. All right, how did you do on those 3 problems, D, E, and F? If you got all 3 of them right, you're doing great. All right, last page, we're just going to show you how you would multiply fractions, what it would look like in a real-world example. So this one says, I'll circle some things as I read it. It says, Frank had half of the lawn left to mow. On Saturday, he mowed 2/3 of what was left. What fraction of the entire lawn did Frank mow on Saturday? So here's how I'm going to set it up. First off, on Saturday, Frank mowed 2/3 of what was left, right? Well, we know in this first sentence, half of the lawn was left. So that means Frank mowed 2/3 of 1/2 of the lawn. And we have to write our answer as what fraction of the entire lawn did Frank mow. So basically, we have to figure out what 2/3 of 1/2 is. And if you guys remember, I hope, of means multiply. So we have to solve 2/3 times 1/2. So I'm looking for some bow tie reducing. 2/3, no. 1/2, no. 2 over 2, yes. 1/3, no. So the 2 over 2, remember, is my favorite because the 2's just changed to 1's. 2 goes into itself 1 time. And when I multiply, 1 times 1 is 1, 3 times 1 is 3. So remember to label it based on your question. What fraction of the entire lawn did Frank mow on Saturday? He mowed 1/3 of the entire lawn. All right, ladies and gentlemen, you are done with me. If you were absent, I'm sure you have some of the guided practice problems below. And if you have any questions, ask me whenever you can. As always, thanks for watching.